Manufacturing Matters is an MFG Radio Network production brought to you by GIE Media's Manufacturing Group as industry experts take deep dives into the latest manufacturing matters, whether it's new innovations, products, technologies, and emerging markets that help you understand better why manufacturing matters to you and also to the top companies in the medical, aerospace, defense, and electric vehicle manufacturing industries. Hello and welcome to the latest discussion from GIE Media's Manufacturing Group. I am Jake Kaufman, the senior editor for the group, as we get ready for another roundtable discussion on the latest innovations in the cutting tool industry. We'd like to thank today's sponsors, Iscar USA and Allied Machine and Engineering. Iscar is a full solution provider of cutting tool products and accessories for CNC machining, launching hundreds of new products for machining each year. Iscar is where innovation never stops. Allied Machine and Engineering is a leading manufacturer of hole making and finishing cutting tool systems. Allied devotes its advanced engineering and manufacturing capabilities to creating the widest selection of value-added tooling available to the metal cutting industries across the world. Also, we are lucky to be joined today by some of the top minds in that cutting tool industry. Tom Rohn is Iscar USA's Chief Technical Officer. He oversees a team of product and industry specialists responsible for developing and articulating cutting tool application strategies that maximize cutting tool utilization and drive productivity improvements for many manufacturing customers and industries served by Iscar. We also have Chris Bess, an application specialist from Allied Machine and Engineering. He works with local field sales engineers on key accounts and projects to drive sales growth. Not only does his vast knowledge of technical information make him a valuable resource for many in the field, Chris also works as a liaison to projects requiring custom tooling. Without any further ado, gentlemen, let's begin the discussion. Thank you so much for your time today.
Man, thanks, Jake. Nice to be here.
Thank you for having us.
Awesome. So we will begin with Tom over at Iscar. Now, Iscar, we know that they focus on the 3 Ps. That's higher productivity, profitability, and also performance. How do those principles then help Iscar when they develop the new grades and coatings of their cutting tools?
All right, so you're picking right away on one of Iscar's marketing slogans, right? Here,
yes.
The 3 Ps, and I'm going to throw a 4th one out there, get on the soapbox for just a few seconds, and the 4th P that I want to throw in the mix is just process. And, when we, if we keep our eye on the ball in manufacturing, we're looking at how can we create that best process. And, that usually results in creating parts, at the lowest, cost. And, when we look at, parts, we should be looking at, meeting the expected quality of those parts and overall CPU. At the end of the day, if you can have the lowest cost per unit while meeting the specifications, you're going to be in good shape. And so, when you look at the 3 Ps, there's a specific order in which I like to address them because, if you're focused on the cutting tool, for example, and you're looking at the performance, the first P of the cutting tools, you should end up ultimately being more productive. And if you got the performance, you're more productive, well, profitability should be the end result in that lower cost per unit. And when you start looking at you mentioned it in the introduction of Iscar, where innovation never stops. That is the essence of Iscar ever since I've been with them for just over 23 years now, where you have to continuously innovate. And just to give you an example, maybe some people that are listening will not be familiar with the evolution of some of Iscar's product lines, but I'm going to pick on one, which is the Iscar cam drill line, or now Sumo cam line, which was the initial introduction was cam drill of the interchangeable or exchangeable head system, where you had a steel body and then you had heads that you could take on and put on and take off as you needed, and adjust different heads to different materials. You look at that product line, it was only there for a few years before it was iterated upon and improved with what we called cam drill jet. And then a few years later came Sumo cam. Now, Sumo cam has actually stuck in the market now its life cycle, if you will, it's on over 15 years. But that iteration, or that, those looking at how a tool can be profitable for a company, it's part of what makes Iscar compete. And that's another thing, the essence of those 3Ps: to develop inserts, maybe more material specific inserts. If you look at that, going back to the sumo cam, you'll have cam drill or sumo cam heads for ISO-P, materials, or stainless ISO-M materials, or high temps ISO-S, so then you get into specific coatings and substrates for materials that help you hone in on reducing the cost. I'll give you a quick example. Like in milling inserts, one of the popular grades that has been out there for a long time contained an element called ruthenium, and ruthenium had a very good characteristics in resisting the high temperatures and heat that's created when you're machining a high temp material like that. Well, what we did was we said, okay, how can we create something that we can use to machine titanium alloys, but doesn't contain the ruthenium? And what came out of that development was a grade we call IC716, which the geometry of the insert plays a big part in how successful you can shear that titanium alloy material. But also we introduced a different coating called TIB into the mix. And when it comes to coatings, there's so many different variables you can look at, whether it's the composition. One of the big trends in my experience with cutting tools was everything was always titanium aluminum nitride coating for years and years and years. Then it switched around, and we had some aluminum titanium nitride. And then the more recent trend was to introduce silicon doped, what they called silicon doped coating. So you had silicon chromium a composition added to the aluminum titanium nitride. So all of these things, along with, now you talk about coating layers, like having different thicknesses and going from PVD and CVD, and what those different characteristics can do for you. There's a lot of different variations of inserts. So when you look at a company, like Allied or like Iscar, and you're saying, why do you have all these different grades? Well, it's so that we can hone in on that specific material and application, and ultimately get to what I started with, which is ultimately having the best CPU and the best process for your application.
Awesome. Thank you, Tom. So we'll go over to Chris at Allied Machine and Engineering for their question. As Allied Machine and Engineering, they focus on cost per hole. So how does that factor into the latest cutting tools that Allied is producing?
Yeah, thank you for the question. And well said, Tom, by the way. Really like what you said there and agree with everything you said. The cost per hole, a lot of people right off the bat, they're thinking, well, I want the cheapest tool that lasts the longest in that. Of course, everyone does. But the manufacturing costs, when you're looking at cost savings in that, is the bulk of the workpiece cost. Your burden rates on the machine and everything you pay from salaries, insurance, and that to keeping the lights on. So getting these things done quickly really helps. And some of how we do that, especially in some of our recent tools, but we've always done this, is whether that's cycle time reduction through increased penetration rates, like Tom said, having a specific tool. The old Allied, we would have different grades of carbide and different coatings, and hey, just how would you know which one to use? Now it's more, if we're doing steels, we have a P geometry. Now, if we really want to hone in on an application, we make customs and specials specifically for it, but it made it so much easier for these ISO specific material grades, similar to what Iscar has as well. But increased penetration rates, taking larger depths at cut to reduce operations. If you have multiple roughing cuts, well, maybe we could take these all in one, or could we do something with a combination tool? And something that, combo tools, we turn around, industry standard. We're usually faster than most. And that can really help reduce operations, make for a better, just more consistent part. So we really focus on that, and some of our new product lines like we call them our pro lines, but our TA and our Genesis. So the TA is like a spade blade and the Genesis being more like a round tool, like a high penetration, similar to what Tom mentioned on the Sumo Cam, that style drill. These pro lines are focused on, ISO specific materials and really dialing in for those, going faster, lasting longer, the ideal, coatings in that. So that allows us to, drill more efficiently, better chip control. So maybe we can go deeper than the competition, reduce a PEC cycle if they have that. Those are the things we sort of aim for. And there's also like our wall hopper boring line has a product, the vol cut, we call it, like a volume cut. It's you can take a lot more material than like a traditional twin bore could, just because staggered inserts, larger depth of cut. If you have the machine to push it and the application around it, you can cut out cycle time by reducing operations in general. And then just eliminating it by getting it closer to the final bore diameter, I guess is the goal there. But the combo tools, we offer them across our product lines for the most part, but Superion being one of our solid carbide round tools, focused on custom tailored solutions. That's something that stands out to me as combining a lot of operations into one and hopefully helping that cost per hole. And then the other thing is, hey, what if that sounds great? I'm in an automotive high production. That all sounds great, but hey, I'm a job shop. I have 10 parts, but I don't want to spend a fortune getting my upfront costs. Well, we still have high speed steel and cobalt options, and that's not that exciting to hear about anymore. But sometimes it still has a place. It still has a place in job shop applications. A lot of aerospace still uses those material substrates because large parts with just a few holes, they just have to get the holes in and not scrap the $1 million part. Cobalt and high-speed steel are forgiving, so we still offer a full range of that, different substrates. So I would say that's sort of how we focus on just cost per hole, and if you have something, we're very good at tailoring to your application.
Awesome. Thank you, Chris.
Absolutely.
So we'll go back to Tom for our next round of questions. Now, I've seen a lot of new geometries coming out of Iscar. I believe when we had Matt Schmitz on last week for our lunch and learn, he had the Penta. He also talked about the Deca. So obviously, the number of sides and stuff like that are being developed there at Iscar, are just the world is out there where you guys just keep introducing new geometries. So how does Iscar help reduce cutting forces, save energy, and improve chip control while also providing all these edges that you are able to cut with?
Oh, how? So, depending on what technology we're talking about, whether it's a milling insert or a turning or a hole making insert or head, there's something I want the audience to hear, and because I could bore you with Iscar designations and probably even EDP numbers, but nobody's going to remember that. But a phrase or a slogan I want them to take away is chip splitting, equals power reduction, and chip splitting equals chip evacuation or chip control. And when we mention chip splitting, I can show you different inserts from drilling heads that have these serrations along the cutting edge that breaks the chip up into smaller segments. And that can be attractive in terms of reducing power consumption. They all go hand in hand. And, you talk about, if you ever watched a drilling process, if you can't get the chips to flow up out of the hole as you're drilling, we've all seen that horsepower on the spindle spiking up and down as chips are grinding and not evacuating properly. And sometimes it becomes a catastrophic event where the cutting tool fails because the chips aren't coming out. So chip splitting and just being able to press. The other thing I want to focus or emphasize is pressing technologies, or the ability to create an insert, in a green state by pressing it into a unique shape, or having different rake angles and clearances and things that are needed for an insert to function at a high level. That pressing technology is something that has really evolved in the past few years, where even something going from like a hydraulic press to an electric press has enabled more control of the pressing itself, and allowed us to be more accurate and to create different shapes. And going from maybe what you would consider a I guess a modest die set that's maybe 2 pieces or 3 pieces with a punch or something, to what they would consider a 5-axis die set that's very complex, and being able to take an insert, a milling insert, for example, that maybe was single-sided and had 4 cutting edges in the past, now is double-sided and has 8 cutting edges. So now you're talking about increasing the utilization of of that insert, and having those multiple cutting edges, or more edges per insert that you mentioned. But at the end of the day, you look at hole making applications, that's probably the most like power intense cutting operation that we deal with. And you got to be really careful not to exceed the capabilities of your spindle that you're working with, whether it's the main spindle on your on a mill, or on the lathe, or if it's a driven spindle on an attachment on a turret. You got to be very careful. So these chip splitting geometries, to just come back and emphasize those one more time, can be a big problem solver for users out there, to try to reduce that power consumption and enable better chip control or chip evacuation in your processes.
Awesome. Thank you, Tom. So we'll go back to Chris at Allied for our next round of questions. Now, Allied has been able to expand their product range with brands such as Superion, Thread Mills USA, Criterion, and Wolfhopter, I believe is how you pronounced it. Is that correct?
Wallhopter, if you're in Germany, Volhopter, I think would be the more proper pronunciation that I butchered, I'm guessing. But yeah,
Believe me.
Wallhopter, boring.
Okay. So with those brands, how has Allied been able to expand their product range?
Yeah. So Allied is a hole making company. That's our focus. We dabble in the fringes, but hole making is our bread and butter. So it just made sense. If we're drilling a hole, we're roughing a hole, why can't we finish a hole? So the purchase of Criterion, that used to be made in California, it's now made in Dover, Ohio. Straightforward mechanical dial, roughing tools and fine bore tools at an economical price. And then with the purchase of Wallhopter, they're a premier boring line, Germany, made in Germany. They're still made in Germany, but we stock, I would say, a vast majority of the items right in Dover, Ohio. We could bore from micro bores, maybe a 16 thousandths, up to 10 and a half foot area with standard modular tools off the shelf. So just a full range of modular tooling, micro adjust with digital options, balancing, auto balancing capabilities. They're a great product. Between the two of those, we sort of cover your range. If you're holding a few thousandths, there's absolutely a mechanical dial is easy enough to adjust. If you're holding tenths, very difficult to do. It's not impossible, but the digital just makes it that much more reliable. So they were a great addition, and it just made sense for us. You mentioned Thread Mills USA. They're exactly that, thread mills. So very descriptive
Accurately
name.
named.
Yeah,
Yes.
we've been partners with Thread Mills USA for years, but then we actually announced the purchase of them. They've always been great. Have offer multiple solid carbide and insertable options, custom forms. One of our new tools that we call it our T3. It's basically a three-tooth thread mill that acts like a single tooth. It just the following two teeth clean up. It allows us to maybe do longer depths to diameter, very small threads and hardened materials. It really helps that reduction of I guess radial load that you would have in a thread mill. So again, just made sense. It's in the hole making realm. So a great addition there. And then Superion, so much potential here. I know there's a lot of round tool companies in the market, but it filled a gap that I think we were lacking, and I'm really glad that we got Superion. Whether it's a carbide tool, CBN, PCD, Ceramet, these are things that we do at Superion. They are all tailored, custom made. Whether that's a reamer, router, end mill, drill, combination tools. These are all things that we can do. And really, to Tom's point earlier, there's so many options. We take the information of the application and we'll pick out what we feel is best. And it's something that, we stand behind it. We test and do all that. So, from small orders to high production, it's something that we can handle with Superion. And one last thing, Tom mentioned something on the previous deal about drilling and power consumption. Just always a good thing, and it reminds me that there's a customer I had that it was like say it was a 70 or 80 horsepower machine, and we were drilling a 4-inch hole in stainless. They said, "You'll never shut this machine down." I said, "I hope not," but I said, just be wary. There's other things involved here. Is a large WFL machine, and lo and behold, the spindle load barely moved, but the Z-axis thrust or the thrust of it shut us down, and we couldn't feed over like 4 thousandths per inch, which was very difficult to get chip formation, which led to increased power consumption. It just was it spiraled out of control. So I would say that just because someone says plenty of power, this lathe has all kinds of power, it's not just that. The thrust, that's usually what shuts you down on these lathes. So good point, Tom.
Yeah, Chris, that's well said. Those axis servos can sneak up on you.
And you also mentioned something about catastrophically failing a tool. I've never seen that. I've never done that. So, yeah,
Well, it disappeared. The evidence disappears.
Exactly. Just joking.
It happened on second shift.
Exactly.
Yeah, right? The cameras weren't even running then. I don't know what happened. Well, we'll go back to Tom then from Iscar. How can Iscar's versatile, multifunctional tools support the complete machining that you guys see on so many of the latest CNC mill turn machines?
Yeah, so multifunction tools can be fun. They're multifunction, so they're not honing in a lot of times on one application, but they may or may not be more productive at the end of the day. But I think the main thing for people to think about is to think about what these tools can do if they're faced with some sort of constraint, like maybe the number of stations on a turret. A lot of these turrets that are coming out now on lathes, for example, they'll have all these positions, but once you get all the tool blocks on there and get everything tooled up, you start finding out, well, I got clearance issues from hitting a block or hitting another tool on another station. And so you end up being limited on your number of stations. So, you can take either a solid carbide or indexable multifunction tool that can not only, face, turn, and then do traditional turning, can also come down, drill the hole. And then once the hole's drilled, you can use that same tool as a boring tool. And then there's even some that on the backside, if you run it over to the other side of the part, if you got clearance, there might be a thread form that it can produce on the backside of the tool. So, all of these things can, help you if you get into a situation where you don't have enough stations. on a lathe, and you can turn 2 or 3 or 4 tool stations into one. And now you're talking about, you can also get into talking about carbide utilization. If you have a multifunction tool that's able to do what you need it to do, well, now think about the amount of carbide that you're using to do those 2, 3, or 4 operations now, versus the traditional style tooling, in that sense. So, and another thing to think about on the milling side is you might be able to take a drill mill and really utilize that tool. Like, let's say I'm doing a pocket on a mill. Well, I've learned over the years that one of the most effective ways to rough out a pocket is to create a starter hole, usually drill it is the fastest way. And then you come in with your milling tool and you open up your pocket and do whatever you got to do. Well, if that pocket's shallow enough, or if you don't have enough tool stations, once again, in your milling machine carousel, you can turn 2 tools into one. You can take a drill mill, bring it down. You can, you're basically creating your starter hole and roughing out the pocket with the same type of tool, same insert. So it might not be as productive. You probably aren't going to rough out that pocket as fast with a drill mill, but if it helps you out with adding another tool to be able to finish that part, and you're not under a time crunch, it can be a viable solution for you, on that machine. So, and I want to just point out too that one of Iscar's original tools that it was founded on was a grooving tool. And not long after it introduced the first grooving tool, it introduced another family called Heligrip, and that Heligrip was mainly viewed as a grooving tool, but one of the things it could do was groove and then side turn in multiple directions. So people went from, on a lathe, where if you had to open up an area between walls on a lathe, you would have traditionally had the grooving tool to rough out the middle. Then you would have came in with a right hand tool and a left hand tool to finish the feature. Well, this old Heliturn or Heligrip tool had 3 cutting edges, distinct cutting edges. You could groove with it, and then you could side turn in either direction. And if you think about that from a carbide utilization standpoint, now you're using 3 cutting edges on the same insert rather than 1. So there's a lot of benefits of a tool there that was introduced decades ago that really wasn't viewed as a multifunction type tool, but it was.
Yeah. Redefining it, in the future after
Yeah.
it had been introduced. So we'll go to Chris then for another look into Allied Machine and Engineering's operations. So how does Allied's engineering team work with clients to develop application-specific tools? It's something that I believe you've touched on, a few times in your answers, but how is, that engineering team really working hand in hand with the customers?
Yeah. And like you said, I hinted at it, and I think in the last few answers, but I'd say, asking the specific questions, and our engineers, I like to get them involved early on, especially if it's a project, hey, let's get it involved early on. We sort of have meetings about it, and bring the end users and involved as well to get their input on, what is the win for you guys, because not everyone's views that win as the same thing. So, we don't want to assume too much. So asking the questions, usually you get an application, and the information is piecemealed to you, it trickles in. Rather, there's very few, and we really appreciate it when it's all the information's up front, but sometimes, they're not providing it because maybe they didn't even think it was important, but it may change a slight feature on our end. So asking the specific questions, so that we can offer a tailored solution. Our engineering team's great at that. We have always have, your newer and then your tenured older engineers. So it's a team environment, I would say, because if you've never seen something before, how do you know about it? So that's really good in like getting some of that synergy inside, I think, as well. So from seeing it out in the field, getting them involved early. We also take our engineering out in the field too. So They're not just stuck behind a computer all the time. So yeah, just seeing that, and then we can look at what is the win. We need to do this as fast as possible because our throughput is just, we're bottlenecked right now. Is it tool life? I don't want to touch this thing. Every shift will change it, or maybe I don't want to touch it until the next day. That may be a little different tool than what we would to just blast as fast as we can. So finding what is important to the customer and giving them that, and while also offering multiple options is really where that our engineering team helps focus on.
Thank you, Chris. We'll go back to Tom then for our next round of questions. Another thing that you guys have both touched on, I believe, is just the amount of exotic materials that are kind of making their way into the modern cutting tools. What, are those newest exotic materials that you've been able to work with, and what are the changes that kind of added to those, or that led to those being added to the offering from your guys' companies? So Tom, you can start. Yeah.
Okay, great. I think I'm going to touch base on looking at the inserts, or the carbide inserts, or whatever it may be themselves, and then the tool bodies. So of course there's plenty of innovations taking place on like carbide substrates, geometries, and pressing of geometries, and the coatings that make these inserts last longer. But one of the areas I want to focus on in answering the question you just posed is 3D metal additive for creating tool bodies. And there's so many, we're always looking for that good mix of hardness, toughness, wear resistance, stability, in high temp scenarios. So there's quite a bit going on in that area of 3D metal additive in the production of the bodies, whether it's for turning tools, milling tools, hole making tools, you name it. There's a lot going on there, and I think the just the powder that's being used, like the cobalt chromium, or the tungsten carbide cobalt powders that are being developed, and they're being able to print at higher speeds and allow us to create things productively that will last longer, and have that wear resistance and the attributes that we want it to have to hold up under the forces that be when you're using a cutting tool. I think those are the things that are going to allow us to continue to up the bar in terms of performance in our cutting tools in the future. And who knows? I've heard of additive processes being used to actually create the inserts, or those cutting inserts themselves. And I wonder where that's going to go, because you can really press a green insert so fast and mass produce so fast. I wonder where, maybe from a specials standpoint, we might see, certain specials being produced with additive, where the actual cutting insert itself. But it's really exciting to see where this is going to go in the near future with the 3D metal additive.
Thank you, Tom. So yeah, Chris, the same question. What are the latest exotic materials that you guys have been able to work with at Allied, and kind of what led to those being added to the catalog?
Well, I was updating my notes here because Tom stole some of my thunder, but it's good to say, like, the same thing. He's on it. I'll start with where I am at and end with additive manufacturing. But for us, while not new, what I see is it being more prevalent in the industry, and that's your CBNs, your ceramics, PCD, diamond coatings. Those are becoming more commonly used in manufacturing, where carbide may have been used in the past. We use these substrates and coatings across most of the product lines, and have had success in difficult to machine applications like hardened steels, high silicon materials, composites, exotics, or just simple to increase tool life in irons. We're not a indexable milling company, but Tom could talk to it. There's a lot of face mills on these iron blocks and that are using your ceramics and your CBNs and all this. So that's something where I just see it more often. It's by no means new, but they're coming out with new grades and everything, and coated CBNs and that all the time. There's just some really incredible stuff going on there. And then the additive manufacturing, Tom's spot on. Very interesting to me. I dabble in 3D printing. It's not affordable for the normal hobbyist for anything for that matter, but even the normal shop, but it will get there, I feel. And that could help with a lot of things. Everything Tom said, spot on. One added thing to add to that is complex coolant paths is another really neat thing. Like, we have drills in that where coolant holes are twisted into them. Well, no longer. You could go wherever you'd like. You could miss certain features of a drill. You can dial that in, or even sometimes on really long tools where gun drilling is difficult to get a coolant hole in. So that's something. It's not there yet in certain aspects, but another thing you mentioned about the inserts. Prototyping, Tom, I think that would be awesome, because getting these dies made are very expensive. So if you make a few tweaks here and there, all of a sudden you're 3 dies in. Well, we're talking some serious cost and also serious lead time. You can make changes and mistakes in days to weeks compared to months, maybe. So I'm excited to see where that's going, and I think it has a lot of promise.
Thank you. We will stick with you, Chris, for our next round. As cutting tool manufacturers, why is it important to maintain a relationship with the machine tool manufacturers as well?
Very important. And I would say it's great to be on the front end of a machine sale, especially a turnkey, because on the manufacturer's side, if another tool comes in, maybe you say you have a better tool. Well, it doesn't matter. This turnkey was already tested with XYZ companies tooling. And even if you're going to win that business, it takes a certain amount of time just for them to get through the process, to even digest wanting to make a process change. So you immediately lose, on a selfish end, I'm saying sales cycle for us. But maybe the customer also, I'm not saying they feel shorted, but they're like, well, why didn't I know about this up front rather than doing all this after the fact? So just being involved, and we are a niche company. So for us, sometimes it's a little tougher. But staying there and keeping the OEMs, up to date on our newest product offering and why you would use this over that. And we've worked really well with, okay, Iscar would be using the indexable milling or something of that nature, but we have some good hole making or deep holes that really we have a better selection on that. So, and vice versa. And we've tried to navigate that and be able to offer our tools up front on the spindle, whether it's turnkeys, tooling certificates, things like that. But yeah, just getting on the spindle up front is important for us. So OEMs are very important.
Awesome. Thank you, Chris. So Tom, how at Iscar do you guys maintain those relationships with the machine tool manufacturers as well?
So one of the main ways is we do have groups that are solely focused on working with the machine tool companies, whether it's the builders themselves or, mainly in the US market, there's a lot of distributors that represent the builders product lines. And Chris made a lot of good points on why it's so important to be there, which I could definitely, be redundant and touch base on, but there was a couple there that, for us on the cutting tool side, for a lot of our turning tools and milling tools, and if you take turning tools, for example, there might be special block configurations that need to be taken into consideration. So we need to be aware of the latest technologies that these companies are developing, so that we make sure we've got kind of the foundational aspect in place, like we got the right block that allows us to implement our turning tool or our turning solution to their machines effectively without too much, pain, so to speak. And, sometimes, I've always been a big advocate of, if you can make your manufacturing technologies, whether it's the machine, the cutting tool, the cam system, the cutting fluids, all come together at the same time with a synergy, you can come up with that best solution that provides, what we started off this conversation with, which is the best process and the best CPU and profitability. And so, it's very important. We do it through groups that even go back to our corporate headquarters in Teffen, working with the builders that are maybe in Germany or in Japan. And then, of course, here in the US, we have a group of individuals strategically placed at the densities in the US where the machine tool builders and distributors are camping out with their headquarters. And we try to be there as much as we can to meet their needs.
Awesome.
Hey,
So
can I add one more thing to that, Jake?
Of course.
Tom just reminded me, the other thing is helping sometimes with the machine options, especially in the drilling end when we're talking about power consumption. Hey, maybe it costs $30,000 more or 50, who knows? I want a Cat 40. Well, sure, you want that cost, but really you should be looking at a Cat 50 or an HSK 100, just that type, and also coolant pressure and volume, that just helping from the manufacturer's end to help the OEMs say, hey, this is a great machine, but this part you're looking to manufacture, this is how I would do it, and that you're going to need, this, or think about, this is going to be a deep hole. Do you have the travel? Just helping spec out this stuff, because they have so many machine options as well, just sort of tailoring the machine to what they're doing as well.
So before we get to the final question, looks like we do have a few coming in from the audience. So it looks like Isabel, Tom wants to know when you were talking about the ruthenium.
Ruthenium.
Yes.
We used to have a joke about that, but anyway.
What were the benefits of using that against tungsten? I guess, what was the reason that your ruthenium was being used instead of tungsten?
So when it comes to that, the composition and the material science, I don't claim to be a super knowledgeable expert, but I know the base information that the ruthenium had the element ruthenium. It just had that ability. I think I might have alluded to it to hold up to the higher heat as a binder of the material, whereas cobalt, it has a melting point that is traditionally lower than what the coatings could hold up to or whatever. So it's the cobalt, the cobalt's kind of the weak, as a binder, it's kind of the weak point of a sintered insert. Well, having ruthenium in that in the composition of an insert, as a binder or as an element, it gave it the ability to hold up to higher heat and resist heat that's taking place in the cutting zone. But the one thing I could tell you is that the ruthenium as an element, just as a raw material to purchase, if you were to look at like the cost of that element, it's skyrocketed over the past decade or more. And it's one of the reasons why, to try to help customers have a better cost per insert and cost per edge, when that's why we came out with the IC716 that was specifically for titanium alloys, because the inserts that have the ruthenium in them had a tendency to be more versatile in terms of working in the pH stainlesses that you find in aerospace and the nickel-based super alloys and things like that. So if you need that wide-ranging versatile insert, any of our ruthenium-based grades designed for that industry or environment would still be your main selection.
Awesome.
Hope that helps. So.
Thank you. Looks like Chris, we can ask that one too if you would like, about the ceramic inserts. Oh, we lost audio on you there, Chris.
Nope, that was my fault. I
Oh,
had
okay.
I muted, but I'd been answering them through the chat function. But the ceramics, I would say to Isabel, she mentioned a harder grade material. I would say need to know a little bit more about what you are turning, and also I'm just hesitant to give some recommendations from what I see. And I'm thinking ceramics. A lot of what we would use them for is your roughing of irons, some of the high temp alloy stuff. But usually the ceramics in my eyes we're using for the roughing aspect, just because they're not holding a tight form on that, compared to, like, okay, when you mentioned harder grades, like if say it's a hardened steel, the CBN could be the answer. But harder, I guess, is a little bit subjective, because we're saying maybe 55 Rockwell up for like a CBN type. Could it be used lower? Sure, but when you start to lose, in my opinion, you start to lose disadvantage when you say you're around 40 Rockwell or something. Carbide has no problem with that. Carbide can cut 55 Rockwell. It's more of a tool life thing, and that. But yeah, I would say if you have some specifics, if I don't know them, there's people who are much more knowledgeable on that end. I feel that I know a decent amount about them, but if you have some specific application details, Isabel, be more than happy to follow up, or I'm sure Tom offers a full line of that as well.
Yeah, so we will get Isabel's information over to both of you guys once we wrap up today.
Sure.
But looks like it is about all of the Q&A coming in from the audience. You guys can still ask them. We have time, obviously, for Tom and Chris to answer. But the last question I had for you guys will begin with Chris at Allied Machine and Engineering. We've obviously talked so much about the advancements that we've seen in the cutting tool industry currently. But if we have the same conversation in 5 or 10 years, what advancements do you think we'll be talking about, Chris?
So, I think robotics, a lot of it, and we already have robotics in there, but I think it's going to be more refined and just more. You're going to see it more often. It's so hard to find machinists, or even on our end, it's hard to find people in this manufacturing industry. So a lot of companies I know are considering or even adding on to their robotics, whether that's part loading or even cobots. You're working with a human as well, or some of I haven't seen it yet, but these humanoid robots in the Olympics and stuff they're holding with them. I think it's a matter of time, and you're going to see things along those lines, and I think you'll see them more regularly. How long? I would never pretend to know a date, but it's coming, I feel. And with that, and in the addition of AI, I think it's still a little bit in its infancy, and we don't, other than making really cool looking pictures or answering random questions, there's so much more that can be done with that. Improving the manufacturing process. People are using this already, but cutter paths, tool selection, wear detection, I think is something that could help that, along with AI on these robots. And then the additive manufacturing. Tom mentioned it already, but I think it's just driving the price down and making it right now it's not fast. And it's still, in most applications, I'd say it's much faster to take a piece of billet or a casting and just machine it. It may get to the point where it's very close. And if that's the case, these things can run lights out much safer, I guess I would say. When something happens bad, it stops. It's not usually a crash. So I think just making it more cost effective, and it'll be more attractive for the masses. And I think that's something that will just come hand in hand anymore with manufacturing.
Thank you, Chris. So we'll end things with Tom over at Iscar. So yes, if we have the same conversation in 5 or 10 years, what advancements do you think we'll be talking about then?
So touche, Chris. I'm just gonna say ditto on what you just said, because no, but I I will say that I do feel like the cutting tool designs meant to work with automation, that's going to be interesting, to make it so that the robots can either change out a head or change out an entire like cutting tool assembly, like take it from the turret, put a new one in a turret, or take it out of a machine tool spindle, put another one in. Those are kind of the things and advancements that I think we'll see coming. And I think a larger percentage of the cutting tools, especially the bodies, being 3D, printed, and I think, as it was mentioned, AI, I think these generative designs that optimize the weight of assemblies, the rigidity of assemblies, the fluid dynamics, as Chris alluded to, and then, ultimately the cutting tools being programmed and optimized through AI driven platforms. That's what we're going to see in the next 5 to 10 years. And well said, Chris.
Thanks.
Well, looks like that just about wraps things up today, but obviously we want to have a big thank you to Iscar USA and Allied Machine and Engineering for their sponsorship of today's discussion. That obviously means a massive thank you to Tom Rohn at Iscar and also to Chris Bess at Allied Machine. Thank you guys so much for your time and expertise today. Definitely looking forward to speaking with both of you guys again soon.
Likewise, Jake. Thank you.
Thank you so much for having me. I appreciate it.
You can listen to all of our episodes of Manufacturing Matters and Lunch and Learn podcast from the MFG Radio Network on Spotify, Apple Music, and on our websites, todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, defenseandmunitions.com, and evdesignandmanufacturing.com.